So, hello everyone. My name is Kaspars Cēbers and I represent a company called Rīgas Ūdens. It's Riga Water in translation, and I'm gonna give you an insight and introduce you to how GIS is being used in our company. My profession is I'm senior geoinformatics engineer, which is basically a GIS specialist in this company. First of all, to colleagues from abroad, Rīgas Ūdens is a company that provides the city of Riga with public services like drinking water supply and collection of sewerage, and we represent basically the full cycle of collecting water from nature, transforming it into drinking water, supplying inhabitants of the city with drinking water, then afterwards collecting the wastewater and transporting to purification station, and basically channeling it back into the nature as clean as possible. Here are some images of, I don't know how clearly it's visible there, but some images of our infrastructure. And the bottom line of these images is that we maintain very extensive infrastructure, and for the maintenance it's very important there to be a system to collect all the information and maintain all the ongoing changes of the data. And obviously, GIS is what we use. It's Esri supported GIS systems that we use. But before turning to GIS, I want to show you some historical images of how the data were being maintained, I don't know, 50 or even more years ago. And you can imagine that it's basically paper maps and paper schemes that were manually being, changes were being implemented into them, and you can imagine it's very hard work that has been done previously before GIS. And these days still are in the parts of our database. They're still they're still the sources of information of which geometries, for example, come from. And now turning to GIS part, it's actually been 10 years now since the GIS is a word in our company. And in 2008, the first ideas were debated about implementing GIS, and in 2011, the first phase of GIS implementation began, and we're still in this phase. And it basically means that the first phase is just building the core of the GIS system that we have, which is being used like in two ways: desktop GIS use and web use, which I'm about to show in a while. But the key features of our GIS application here in Rīgas Ūdens is how GIS works for us. Is first of all, it's unified database for maintaining our network information and other kinds of GIS data that we have and that we maintain, which are crucial to our business. Second of all, it's obviously web services, maps and visual representations, and those data also works as a source for technical information that's also very crucial. GIS also supports many features that assist on our everyday workflow and various tasks we have to do. And yeah, it enhances the business processes and company as well. And further on, GIS is integrated with other systems, information systems, and finally, GIS is also integrated with other external information systems like state address register. You can see them in cadastral information, topographical data from development department of Riga. So here are two environments, GIS environments, how we work with GIS. First of all, it's desktop GIS, which is being used to create data, to edit data, to enter data into our system, to capture all the ongoing changes in our networks. And second of all, it's WebGIS, which is available to every employee of our company, and it's a very comfortable way to check all those data we have and see the technical information about our networks. Very briefly about desktop use. It's used basically to edit, as I said, to edit data, to update GIS data, depending on various data sources. We have kind of like two kinds of GIS users, more advanced, which work with geometries and they do like more difficult, more complex GIS tasks to keep the data up to date. And also we have like adjusted and simplified desktop use for employees who are not so like GIS advanced, for example, and they just do simple tasks, which also helps to maintain our data, make our data better. We work with versioned SDI database from the technical point of view with dozens of users who implement the changes in our data simultaneously. And also we use custom ArcGIS tools which are developed by our system developer, which is Envirotech. So yeah, that's why I'm here to present you this. That's it about desktop, and I'm now going to turn to WebGIS and here are some key features of the WebGIS solution that we use, and it's first of all it's maps, of course, web services, it's searching feature that we have where we can search any information about clients or addresses or any elements of our infrastructure, because our infrastructure is quite complex and therefore if you need to quickly find a water hydrant, for example, you can easily do it and locate it on the map and print the map afterwards. Also, yeah, it's available. It's possible to edit the data, change data via our WebGIS system, and there's also a feature, documentation browser, let's call it, which supports like finding the large amount of different kinds of documentation that we have on our servers. And also the very important feature is dispatching system. It's a system to register, overview, and control the ongoing maintenance processes of our infrastructure. And here you can see the colors are a bit weird, but that's all right. You can see this is our WebGIS. We call it Rīgas because of Rīgas Ūdens, like the initials of those words. And here is the way it looks, and you can see on the left side there are a list of different web services, large amount of web services. There's that beneath it, there's a searching feature, and also an option to view our client data. And on the right side you can see there's some kind of water pipe selected in the map, and you can see its attribute information, you can see material, you can see diameter of it, and many different kinds of attributes that we gather. And one of my main duties here in this company is to maintain web services, and I'm going to show you a few web services that we have, because we have a lot of them. And for example, here is web service where we display water pipes and water pipe information and you can see basically the complexity of our data. You can see the scale is 1 to 200, and we usually work, our employees work in very large scales, very zoomed in into our map window, because the elements are so nearby each other. And yeah, here is a sewerage network web service. You can see there are different kinds of elements there, and the symbology is quite complex. You can't really maybe see it like here, but it's very complex, and our employees have managed to dig in the complex symbology, which represents huge amount of information, like labels on the sewerage pipes, represent material and diameter, and also a year of construction. And there are more features to different kinds of elements that you can observe here. There's another web service that is quite new, and that's one of our GIS tasks now, to collect information from various data sources that we have in our company to get as much information about the years of construction of water pipes. You can't probably see much about it, but you can see that the years of construction, they differ a lot. There are pipes that have been constructed in 19th century. You can see, for example, here, 1875. There's still pipe there that's over 130 years old. Also, raster images are within our web services, and this is, I don't know precisely how this is being used still, but obviously people still use these maps, and for me it's just interesting as a kind of a map geek. I just like to take a look at those historical maps and schemes. One very important feature is our client information representation, and you can see, I hope you can see, there are symbolized points where you can see active contracts with each address and what way of contracts we have. Blue contracts are water supply contracts, and red ones are sewage contracts. And the lighter yellowish color is wastewater contracts that we have, and it's very easy to see it on the map and see which address has what way of contract with us. I turned all web services on here. You can really tell anything about it, yeah, but this represents the huge amount of various kinds of information that is being used, and it's important to us in our everyday workflow. Last web service that I want to show you is the web service of our dispatching solution that we use to send our units to some places where there have been some bursts into a water pipe, or any kind of damage or repair works need to be done. And this represents again, it's a kind of complex symbology, but it represents the past events and the ongoing events that are happening, yeah. And here is the dispatching, the view of the dispatching solution, and you can see there, this is a system where you can register, enter new event or task where some kind of repair works needs to be done, and it's connected with GIS in a way that you can, any of those events are connected with address information. You can locate them on the map. As well, you can locate objects that have been connected to that specific event, and you can see immediately on the map for example, this element is a wall where you can lock the pipes with it, and you can see that there have been some kind of damage to it, and some repair works have been done. Well, GIS impact on business processes. Well, to tell this whole in brief, it's basically it's very like GIS makes easier to get data, to get technical information, and the information can be higher quality and can be more easily maintained, and also there are different kinds of application to it, and for example, yeah, there are reduced need to use other data, external data, because they have been integrated into our system. And one more important point is it's easier way to create various statistical reports and analysis, and so therefore, yeah, helps to make more precise business decisions. And in conclusion, I want to tell about some ongoing things that are being developed right now, and we have a mobile version being developed, as well as we work with dashboards, and also the third one, which I have mentioned, is data accuracy, which is very important thing, because we still have various data that are not like super precise, and we're working to get it more precise. And here are some images of our mobile. This is meant to be like a smaller version of our web GIS, to include most important features of it, like address search, or any kind of our infrastructure element search, or web services, most crucial web services. And as well, you can see, for example, here is represented client information, and you can, yeah, for example, check some measurement device right where it is, and validate those data. And that's still in development, and we're thinking of ways how to make this more comfortable to use. And dashboards here, for example, you have seen this has been recently made, and for example, this dashboard represents statistical data of our network, of our infrastructure, and see, for example, the amount of hydrants there, and you can click the hydrants and see on the map which hydrants have been built in which year, and yeah, also other kind of information about water pipes or sewerage pipes. And so, yeah, thank you. That's about it. What's with the questions?
Yeah, there is one question. I see two. But it is in Latvian, so I would like you to read it, to translate in English and answer into it, because I do not know Latvian.
The first question is, do you share your information with other companies? And if yes, then what kind of system is being used? We obviously share our data, yeah, with other institutions, because, well, that's kind of our duty. For example, with fire with fire workers, yeah.
Okay, yeah.
I don't know.
Fire.
Yeah. Because they need to have information about hydrants, and we maintain that information, and therefore we share it. And we have also other kind of information with, for example, with the development department of Riga. We share our data, and yeah.
Okay. So, any questions? If no, so thank you.